What's up guys, Mr. Solubility with another video. This video is going to be short, I hope. I apologize for my crappy voice. I hope this is not some indication of illness. This time around, we're going to learn about solubility curves and relationship between solubility and temperature. We will also learn about the process of crystallization. As you can see, this is a plot of temperature versus grams of solute per 100 grams of solvent. It is important to point out that just like the solute, the solvent is also measured in grams instead of the volume in milliliters. I want you guys to look up the reason behind this and discuss in class. As you can clearly see, for most solutes, the solubility, which is the maximum amount of solute that will dissolve, increases with a rise in temperature. So what does that exactly mean? As you increase the temperature, you will notice that if we take KClO3 for example, the line is steadily increasing. The same for KNO3, which is potassium nitrate, and you will see that it is a steep increase. Similar case with NaNO3, which is sodium nitrate. Over here for potassium iodide, you can see that even at 0 degrees Celsius, a lot of potassium iodide can be dissolved in water. So this is ice cold water. And as you slowly raise the temperature, the solubility also increases. So this graph is pretty easy to understand and read. Now, let's talk about ammonia, NH3. You will notice that as the temperature increases, the line for NH3 has started to go down. That indicates that as you heat the water, so the temperature goes up, less and less of ammonia is going to dissolve in water, which kind of makes sense. If you know this already, ammonia, which is NH3, this is a gas. And we know that gases like to move a lot. So if you raise the temperature, the kinetic energy of that gas molecule is going to increase, and that increase in kinetic energy is going to help the gas escape out of water in the atmosphere. So that makes sense that if you raise the temperature, then the solubility of ammonia, which is NH3, goes down. So to sum up, for most solids, if the temperature goes up, then the solubility is also going to increase, and for all gases, an increase in temperature will indicate a decrease in solubility. So let's talk about how to use this graph. So say for example, we choose KNO3. Okay, so this is the solute we will be focusing on. Say we want to find out how many grams of sodium nitrate, which is NaNO3, so I apologize, at 30 degrees Celsius. So all you need to do is get 30, which is right here, and you trace it up to the line. So 30 goes up right here, and it looks like that's around 95 grams. So 95 grams in 100 grams of H2O at 30 degrees Celsius. There will be an exercise we will do in class that will further help you practice the skill of reading this chart and figure out exactly what the lines mean and what they represent. Next up, I want to talk about what are the three different types of solutions and how can you tell what type of solution you have based on the solubility curve of a particular solvent. The first type of solution is called a saturated solution. The second type of solution is called an unsaturated solution. And the third type of solution is called a super saturated solution. Now, as you can see, I've plotted 3 points on this graph indicated by 3 different colors. So I have a black, red, and blue, as you can see. And if you notice, the black point that I plotted falls on the green line. The red point that I have plotted falls underneath the green line, and then the blue point I have plotted falls above the green line. And so let's try to figure out the values for those points. So if I look at the black point, which is this right here, the value for the black point would be 120 grams at 60 degrees Celsius. Similarly, for the red point, it would be 100 grams at 50 degrees Celsius, and for the blue point, it would be around 145 grams at 40 degrees Celsius. Now, what does that signify? The fact that the black point is falling exactly on the line tells you that the solution is holding or has already dissolved the maximum amount of solute NaNO3 that it can dissolve at 60 degrees Celsius. So as long as your temperature stays at 60, this sample of water cannot dissolve any more than 120 grams of NaNO3. Now, what happens if your temperature stays at 50 Celsius and you have 100 grams of the solute? As you can see, the point is below the line. When the point is below the line, that signifies that your solution is unsaturated. It means that you can still dissolve more. And what does it mean when the point you plot is above the line? That tells you that the solution is supersaturated, which means that at this point, the solution is overloaded. It has dissolved more solute that it can handle. And so at that point, this is a very unstable state. So the solution is not going to like being supersaturated. And so what does it do? It is going to take this point and drop it down to the line. And so if you look at the intersection of the blue line and the green line, which should be right around here, how many grams is that? Let's trace that line. And I apologize if this is not very accurate. It's kind of hard to do with the stylus. So we will say that that is around 100 and let's call that 105 grams. That means that at 40 degrees Celsius, the most you can dissolve is 105. But you have dissolved 145. And so what happens to that difference? What happens to that 40 grams that are left? They come out of the solution in the form of crystals. And that means that if you want to make crystals, then you have to start off with a super saturated solution. You will never get crystals from a saturated solution, and you will never get crystals obviously from an unsaturated solution. So the only way to get crystals of any kind is to make a super saturated solution first. And we will do a lab over this, and hopefully that will help you understand the process better. So with this, I hope you have a fairly decent idea of how to read solubility curves and how to figure out the solubilities. And please remember to download the PDF file that I have uploaded along with this video in Classroom, and make sure you print it out. If you don't have a printer at home, go to the library in the morning and take a printout. You will need this for your class on Monday. That is it for this video, and I will see you next time.